So, I got triggered and now I'm going to stimulate based upon like basic shit for physics here. Because I was watching a YouTube video about this for quantum tunneling. Okay? I'm like, alright, well, I like quantum tunneling. In fact, I use it in a lot of my concept designs for a reason, and I do actually know how it works. But the only reason why I'm really quite certain of that is because it was like, okay, so I described it first to these people that really knew what it was, as, oh, well, then wouldn't it just be like a field that, like a fluid that goes through like a fluid very low frictiony, that kind of thing, if it's an energy barrier of some kind, right? So it'd just go like through, It's like a bunch of slots, but then it goes and then it goes, and then, it's that, right? They're like, no, that would work, kind of, but that's not what that really is, right? And I'm like, right. So then it's more like a superconducting magnet that happens to have ordered field lines that then, anchor something, right? And then it goes through much more easily. Except in this sense, we're talking about like a barrier and then it goes through. And then we're also talking about the fact that like a barrier here is not in any way solid and that it squishes a little bit and then that creates its own given type of informational pressure wave, quantum thermodynamics, on the other side. Of course, depending on the size, structure, and everything else, that of course increases its likelihood of being faster or slower, because that's a given type of medium kind of stuff, But they were like, "Oh, that's definitely how that fucking, like the little weird superconducting field that, yeah, with how they get a magnet to stay there, is effectively what that would be, yeah." And I'm like, "Yeah, that's what tunneling is. That's why I like to use it." Because it's really low energy, right? And it's like if you do it right and you resonate things the right way and you affect the energy barrier the right way, it goes through a lot better. Basic stuff, That's how all of our pumps work. Okay, that's the thing. So it's like instead of like ordering it like a superconductor, it's just like, oh, well, this is one of my very first episodes or whatever you want to call it out on YouTube, where it's like, all right, so I'll affect it a very particular way. I'm going to entangle it over here, but actually it's not entangled, okay? There's nothing there, right? It's a bunch of fields that are collapsed in a kind of like superconductor magnet-like capacity, but it's not. Really, we're just ordering them and keeping them around, electrostatic, electromagnetic, trying to have them collapse, blah, 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 right? Yeah, so that way they kind of mimic a vacuumy sort of virtualization of a particle. Okay? They're not really there, nothing's actually there, and in fact the particles aren't really there. It just sort of gets to being close to what this one is over here. Then I'm going to put a field right here, right, that's next to this, and it's an electron in its orbit, and then I'm going to excite it. It might just be able to become a photon, not a proton, right? And then, oh, well, no, I removed your possibility of becoming a photon and going back in your orbital orbit as the electron that you are, right? But it's already tunneling to be able to even try and do that. So once that happens, it's like, well, it can't go back and it can't make a photon. So what does it do? It traverses space and time. And it goes, oh, I was already here. So now I'm there. Because that's in its own type of superposition, except as a quasi-superposition. Right? It can't really be a superposition in that sense. A superposition is hung around, super ordered, all this. No. So instead of that, it's like, no, I'm going to break you down into a quantum informational wave that then collapses on the other side, kind of like the superfluid and the ordering of that electromagnetic field that then pops up onto the other side as a tunnel. That's literally how quantum tunneling works, by the way. I'm describing it. Of course, I'm not getting into hyper specifics about fields and these charge values and spins and more crap, because I have to get into moving, electromagnetic fields and electrostatic fields that have to be also altered with light, right? But they can never hit these actual areas because, like, oh, well, they're not there and they're resonating off of each other, blah, blah, blah. But that means there's a space here, right? A space then that sees itself with those fields and how they collapse and how they spin as being like they could become a particle. Which in reality, it's not like they could become a particle. It's more like they are that. except they're not. There's nothing there. See what I mean? But everything else around it, because that's how an energy barrier works, says that there is something there. That kind of thing is what I'm doing. That was for a silicon transistor. That's right, to make faster than light styles of transisting occur in multiple different aspects, using clock cycle superpositional qubits, which are possible in this instance, while also having wireless transmission occur. And it doesn't actually have a distance that it can only tunnel to. Okay, this is the coolest part about the entangle and the slight superposition that's there. It is not relative to the amount of energy that you put into the system. It will tunnel however the amount of distance it needs to tunnel to get to that point. And that's what I like about it. It means it uses no energy, which is what she kind of goes on about for the YouTube video, except it's not technically doing that. It's getting energy from everywhere around it, as that is an informational pressure wave as it moves through a given medium. As it goes through, it then has that given slight push and this, that, and that, and that's constructive interference as it then collapses towards something that's already very much similar to it. And then it comes out as the information that you had before. Now, the information previously is gone, but the vacuum left before is proportional to the information that you have now here. Conservation of information is maintained. That is why, even though it sounds like I don't know what I'm talking about, a bunch of idiots are what they are. You know what I mean? Like, it's really hard to talk to you about this. No offense, you don't know much about this. I'm going to have to relate this in a way that makes it so it's much easier for you to understand this. You probably don't want to go through mountains of textbooks and shit, because I didn't, and I fucking had to learn this somehow, right? So, that's what this would be. Like, I have to get this really good at being able to, relate it to your head, be analogous to things in your life, and be very simple for you to understand. All right? Now, it is actually relatively simple that way. And I wanted to make it on a nano scale. Right? So that way I could actually compete with regular, actual transistors. And they're fairly easy to do, for what it's worth, because we already have like nanometers that are in the 90, 100, whatever. That's fucking just fine with stuff like this, for what it's worth. Because I have a clock cycle error correcting qubit that I can detect in multiple ways, then I don't really have to worry. You know what I mean? That's the best part about that. But that's the concept that I have. Concept is concept. But so is like, oh, well, look at this. This is a great experiment that you could possibly run. Yeah. They never really seem to think that, the PhD seems to be more of a validity factor, than something else of it's still a good idea. You know what I mean? So, I don't know. It's just a stupid thing that I end up dealing with. But I'm going to move on because it's like, well, it works just fine. Right? But I wanted to do it even better. Right? So it's like, if I create those given field collapses, and I create those given tunnel fields that I need, because that's what that is, right? I then can form the Nobel Prize winning kind of style of, this Bell, whatever it was, a probability thing that this guy did with fiber optics and a bunch of light for entanglement, right? And I was like, yeah, but I want to prove that it's both self-relative and that it knows exactly where it's going to go, and that it knows what it is, and that it's definitely two separate things, and it equals this thing. Or that it's exactly this one thing. Definitely, right? Now, in an indirect method, I can absolutely observe this to be exactly what it is, and even itself observing itself, as that, of course, affects itself relative to everything for the fields around it, right? Because it will then tunnel, and it moves faster in light, presumably, to the detective method, and collapses its given wave function to whatever type of entangled photon, whatever it is, it then comes out as being whatever it is, either at the point it was created or only when it actually gets detected. By classical means, basically. So I wanted to know if whether or not the theory holds up, right? The quantum theories that people have postulated for a while. This breaks down the idea of special relativity not being a thing anymore, or it makes it a definite possibility that's totally unable to be ignored now. As in, it makes it for sure, certainty. It also means that it becomes super determined. The moment it becomes created, it is determined, super determined. P-value stuff. Which is wonderful, right? However, that also means if we don't know what the outside of our universe is, then it either is a chunk area, and we have to ultimately figure out within a closer and closer degree to us, like these tiny little things in a little planet here, that we are, that we can then determine things. Because if you think about the closed system, relatively speaking, that we are of our planet, chaos theory mathematics dictates that effectively we would be able to determine the vast majority of everything around us. Now, if it happens to also get to the point where there is no actual outside and it just continues on infinitely, that's wonderful in a sense, but also it destroys the Big Bang Theory in a way. But it might not. I'd move on because that's causal set theory to a degree with a modification. So, however, I'll also go with if there is an end, that means we 100% can determine everything inside of our universe. Now, that's also within relation to the fact that you'd be able to know enough about that, right? So you have to have a lot of calculating power. Standard problem, But we can always build that to be better. You can always build bigger and bigger systems and hook them into more and more observational methodologies in a broader and broader scope, to the point where you get to the entirety of seeing all of the universe is doing as one relation to one sensor, as that breaks it out forward and rearwards. Causal set theory, chaos theory mathematics stuff. Predictive analysis to a degree, but no, actually, the only way that this could happen, the only way that that could happen, the only way, and then you get everything. But what that does also mean is that anything that might be outside that is affecting us is something we can 100% with certainty say it's outside. And it affected us. We can determine what's inside of our universe, and everything outside that might affect that, we'll know about it. Big brain move, you know what I mean? Right? It's like, well, if there is something out there, well, what could it be? Is it another universe? Is it this? Is that? What is it? Right? I like to go on about that sometimes, but this is not that kind of video. So, I'm going to move on to the reason why I like tunneling is because it's super cheap and efficient. And it makes it so it's incredibly easy, ultimately speaking, to detect and sense almost everything around you if you know what to do. And it's really, really effective at doing it. The only way something from this angle, something from that angle, something from over here, and as it cascades through, can do any of that is because it tunneled this way. And that's a type of energy barrier. The different ways it collapses gives you different detection methods. That also means you know the amount of energy, the directionality, the spin, the polarization, and whatever else it might be. Not just light, but we also get gravity, we also get nuclear forces, and more. Whatever that might be. Because of course we have the supersymmetry to either prove or disprove. That kind of thing, right? It's like, well, it hasn't been proven. We have good, strong indicators, but it hasn't been proven. You know what I mean? That kind of... from people, right? But it's like, hey, this shuts that whole conversation up. It's this now. Whatever it is, it's this. Get it? Same thing for like, no, okay, there's an A and B, but it's very likely to be photon A. I'm like, I gotta go through all these different fields as it goes through this fucking fiber optic, as it goes through the, and it self-referentiates and goes through in tunnels and more, depending, ultimately speaking, on how it's going through, either as a tunnel or as a standard wave propagation, as that also happens, right? There are different energy barriers. We're talking about many different quantum foams and noise, right? There's a lot of different fields that get created from that. The very idea that we detected it correctly is stupid. So we go with, yeah, no, it was a really great Nobel Prize winning, thing, but at the same time, it is not an accurate enough picture in any aspect, and fuck your idea of locality right now. Are you kidding me? Fuck that. I know that you think that that's good, and I know that you think, localized and non-local and real and whatever will stay the same, but this will 100% change it. Either to being there's no more debate, or there is exactly all of that was wrong, and you just didn't do it right. And there's no more debate. So fuck you, basically. Right? Yeah, and I like that. That's why I designed it. It was like, I don't like you arguing. I personally think this, but okay, fuck off. It's very obviously going to be this, you fucking dick. I don't want to hear you. Always devolves. Smart people always get to a point where it devolves like that. It's kind of stupid. But like, aren't we all? We're just animals trying to figure shit out, It's hard. It is. It's very fucking difficult. But I still contend it's like this. It's like, let's do this instead. Why would I want to do that? That would make it so I can't argue. That's kind of the point. I don't want to argue anymore. I just want to know. Meanwhile, the other side is also, right, but what about our smashing? Yeah, but that's a different medium, isn't it? In a different context. Right? Like, it's this amount of energy, this amount of medium, this amount of density, this amount of, like, all these things. There's no way in any aspect it would be relevant to a degree. Except it is. It definitely, ultimately, has that stuff going on. But now you'd be able to determine it far better with this methodology. Right? So, like, you can actually capture a boson. You know what I mean? Like, you can actually capture that. Which, wouldn't that be nice? It wouldn't be able to decay. If it ever formed, you'd be able to fucking get it. I would love one of those things. Like, that'd be so fucking expensive, too. Like, yeah, I've got the only boson in existence. Get out of here! No! This is mine! This is my boson! Get your own! I smashed little tiny particle smashers for fucking a decade to get this. Get out of here. How many particles was that? I don't fucking know. It just ran 24/7 through 65. It never went down for fucking decades, bro. I started adding more fucking shit to it. Can you get out of here? We don't like you. Give me that boson, though. You don't need this boson. My boson. It's your own boson. Aren't you working over there in the big smashy thing? Stop taking my boson. It's my boson. Meanwhile, I'll pay you with antimatter. No, I'm good. I can make my own. Look at this. This is a vial of antimatter. Fuck off. This is the only fucking goddamn thing. Get out of here. It's the only fucking boson I've got. Fucking bastards. Always trying to take my boson. Ah! Thieves! Anyways, that's my boson. I just took it back. Because it decayed immediately. It was just too far away from me. Boom. Some of those field jokes, I should have known! It was booby trapped! Exactly. Should have known. Anyways, but for me, it's like, all right, well, I would love to be able to do it. I got no money. And I certainly don't have the PhDs or credibility that other people do, you know what I mean? So it's never going to really probably happen. But it might. That's a thing. I would love to, truthfully. But then there's the other problem of like, well, I love how I can describe it so easily, but it's like I'd have to get into the weeds with actual people that know what the hell they're doing. You know what I mean? Because that's kind of a thing, right? And that one would turn into we need collapsing spin, which is why almost all of that has a given type of a switch. That's like I pulse this and then I switch over to here and then I pulse this, but I actually don't do it the same way, right? And I have to do it like that, and that creates a different type of electromagnetic and electrostatic spin, and it creates with that light like a good, nice type of negative and or positive like field, right? It also means that I'm forcing a type of idea, which is why I call it a virtual versus a quasi, because a quasi would not be, that's more weakly interacting, but you know, but it's technically not there. Like even a virtual is not, like virtual would technically be more because it actually exists, right? So like this really doesn't exist. This is a vacuum. This is a genuine like quasi virtual in that sense. Which is why I named it in that in my videos for what it's worth. But it's also one of those things where it's like, well, it wouldn't be easier. I don't do that because like silicon kind of sucks, you know. And I developed it even further for a long time just because I needed to. Sucks to like how the fuck I need to make this easier and easier and easier and easier and easier. I need to make this fucking factually cheaper and cheaper and cheaper and cheaper to do. And I need to be able to turn this into more and more sensing and detecting that's like far more understandable and more amplificative and more denoised and more, right? I just need more. It just sucked. But like that's the progression that I ended up going through until I eventually went to like we're just talking about different densities and different connected like styles of vibration after a point here. That's all we're really doing in a quantized momented way, right? Because like we're not talking about like a type of fluid that most people would ever understand, right? We're talking about a fluid that gets like these little bunched up kind of spin jiggle wiggles the right way that cross around in different paths that create their own area of effect, and then we only can measure these little tiny things versus this very much more empty, except we know it's not very empty actually at all, you know. But we like to put it in a graph that's 3D, but it's like, no, that's just like not correct in any aspect actually. It's just a bunch of balloon soupy crap that's just like, and all of a sudden it got a little bit whiter here, and then, you know. So I was like, well, there's a way to do this better if we just think about it like a quantum thermodynamics, fluid dynamics kind of course, right? Like just kind of do that where you use a type of field of any sort. Because like particles are all fields and fields are all particles to a degree, but like of course we're talking about cutting it and then wrapping it off. You know what I mean? And it's like cinch and then cinch and then it's spinning and collapsing and it sticks around, right? Except you have to do the little compressy wessy and then the boom 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 with everything else around it, and it goes and I guess I'm doing it right. But that's how I ended up doing the quantum tunnel stuff for virtual particles. Right? Like, that's literally what I wanted to do, to be able to make, like, a bunch of hydrogen after a while, so that way I can make my plasma fusion engines work for intergalactic space travel stuff. Because that was my plan, basically. And it's like, well, it turns out actually it's totally doable. You just got to get the right material and shit. It's just quantum foam. It's everywhere. So, turns out, not actually that hard. It takes a little bit of energy to get it started, but it's like a Stirling engine, and then it starts going and going and going. So, like, that part was nice. But then it's like, yeah, but how much energy are you getting from quantum foam? And I'm like, how much energy do you get from latent heat energy in your heat pumps? Like, like, honestly, this is one of the reasons why I ended up putting out the other video that was all about how to concentrate heat, waste heat, which is basically what we're talking about. It's a randomized momenta, right? All those particles are just randomized momenta shit, basically. So then we need to order them a little bit and then have them all start heading in a given direction, which we start using Lemke principles because, of course, now it's the quantum. We can't call it the Laminear. We can't call it the, fucking Bose-Einstein. We can't call it, you know what I mean? Like, I'm that guy, like everyone else, right? But we also can't call it that it's, I love this, it's the Bernoulli's and Venturi effect combined, effectively. It's like, it started to accelerate, it then got more ordered, and then it became, there's space there, right? And so that starts sucking things in, and that becomes a Venturi. That also creates more of a lower pressure where it used to be, which creates, of course, the Bernoulli's. Standard stuff. They're always intricately linked, even if we don't like to talk about that, But, like, it's, in this instance, not very possible to laminar it, you know what I mean, and order it and then turn it into, like, a coherented wave function, all right, very easily. So instead, it turns into more of a, well, I'm not going to do that. I'm going to cause it to collapse and tunnel and spin the right way to create the right, correct pressure, which isn't really technically the way to put it, but it's like, it's a vibration that collapses itself, and then it's like, oh yes, I shall now then go around a vacuum place to then go to this, and woo, and then I go on to another one, onto another one, onto another one, which is a type of tube, so to speak, that you can then resonantly, harmonically frequency through, okay? Which is why I always described it as a quantum thermodynamic rather than a standard quantum mechanic physics of any sort, because it's not. It doesn't use any of theirs. It would never do that. It can't even, like, most of them are never using chirality, right? And I'm not using a type of chirality that they would ever know, because it's like, this is a double vortex on one way and the other way, and it collapses a very specific manner to make that happen. It literally doesn't make sense to, like, anybody else that I've ever fucking talked to, let alone anyone else that's, like, ever talked about any of these quantum effects. Like, this is the waterfall, we're trying to use this specifically to get our own type of superconducting cables. I'm like, yeah, not what I'm gonna do. Fuck that. Use the idea that things are through a given medium and vibration. Why don't you do that right? You know what I mean? It just gets boring after all. There's another reason why I was thinking about tech ingredients, right? And I'm like, well, I kind of made a big, long kind of comment on this video, but if you happen to get it the right hub and you happen to do, like, the right intake with how that intake comes in, and it basically starts getting some of that air to mix together with the air that's already coming through, it might slow it down, but you gained a greater mass. Now, depending on how much mass you get and how fast it's actually traveling, you gain a potential constant increase of thrust, which is an augmenter is talking about. So I was like, well, that's basically like a different type of version that I would use. I order a type of augmentation of this given area around, but, that's a lot harder to do with fields, so I'll make fields as a part of something that's already there, a material, right? So then as it goes through, and then I know that there's this thing over here on this side versus over here, they make the right fields throughout all of it as they collapse, and then they get pushed in, they go and down the line, and then back they go. Basic stuff. We've done that so many times, I can't even tell you. Right? That's like a lot of thermoacoustic shit. So it's like, I'll just do that, but better, because fuck this bullshit. But it's like, it needs to spin the right way, it needs to spin the right way, it needs to collapse the right way, it needs to tunnel the right way, it needs to send the right given wave collapse energy around a given media, which is how you have to think about it. Because, like, even though there's a vacuum there, it's a bunch of fields that are energy barriers that it's all collapsing, but it's not really, because it's really just, you guessed it, information going around something and through something. Because, of course, as that moves, the size and shape and volume of that given vacuum also changes, which is information, and then it collapses. Basic stuff. You got to think about it the right way. But if you don't, then it's like, what the fuck did I just hear? I don't even know what the fuck I did. What the fuck? And I'm like, yeah, okay. Anyways, a little, bunch of metal sponge over here, and yeah, what do you know? And I'll just, take that information. No, that's what it was. That's what that was. That's what this was. That's what that was. Okay. Turns out it tunneled over there, though. Or, oh, well, that's good. Okay, then. All right. Faster and light communication. Ha! Suck my dick and balls. Like and subscribe. Bye.